Am I audible in the back? Yeah. So, what were we doing in the last class? Any idea why this situation in the class? No idea? Okay. So, what were you doing in the last class? Standard solutions. So, what are these standard solutions? Hmm? What are these standard solutions? अगर इतना है तो फिर we would as well not have covered. What are these standard solutions? Okay. So, 5 categories है, substance है, field है, that is one thing. But what is the importance of standard solutions? Why are they important in the first place? तो क्या है तो आ जाएगा, but what is this concept of standard solutions? It's like a language for inventive problem solving, where Altshuler said that all that 40 inventive principles, all this technical contradiction, all that is there in its place. But how can I help everyone be an inventor? Not everyone will be able to read all those inventive principles, or even if they are able to read, can I make it simpler? Can I have more people invent better, easier? So he then defined this language of inventive problem solving. And this language is that of substance field diagrams. And in that language, he said there are only 76 constructs. Oh, okay, we know he went up to 85 also, or more also later. But he said 75 are good enough initially. 76 are good enough initially. And he said these 76 constructs, if you know, then you can almost solve any inventive problem that you are facing. All that you need to do is abstract your system in the format of a substance field. Once you are able to abstract your system in that format, then these standard solutions will help you. So what he did was he said that in this language, the components can either be substances or fields. So what are substances and what are fields? So they're all components of my engineering system, but which one would be called substance and which one would you call fields? Components that have a rest mass are substances. Components that do not have a rest mass are fields. Then he added that in any substance field diagram or in any engineering system, for it to be good enough, it should have at least 2 substances and 1 field. If either 2 substances are not there or if 1 field is not there, then it is an incomplete system and it would suffer from some challenge. And then he said that once we have organized or abstracted an engineering system in a substance field model, then there are 76 different models which could be possible. And those 76 different problematic models can be solved in as many number of ways. Now, 76 appears to be a large number. It is a large number. So what he did was he said that, okay, I will organize them into 5 categories. That substance field models have 5 different kinds of problems plaguing them, or you want 5 different kinds of improvements in substance field models. Therefore, he categorized the solutions into 5 categories and subcategories at that. But what that did was that reduced the overall effort from looking from 75 into looking for 5 and then looking for another 5 or so on. Are you getting it? So it eases your design process. Hmm? And he talked about different kinds of fields. We discussed that MATCHEM is one way to remember something: mechanical, acoustic, thermal, uh, chemical, electrical, magnetic, and optical. So MATCHEM is one way to remember which kind of fields can be used, can be there in the system. And then many of you, when you were analyzing your problem statements that you are working on in the last class, you said that you asked questions like, "Sir, अब ये physical touch तो नहीं हो रहा है, but uh, should I make the wire there or should I make the visual thing there?" And then say field is like light is a component, and then I say light. So we agreed that no wires. Even in the example of a paint filling system, we said wire is not needed. Did we model the wire? The pump was not physically touching the motor, but we said they are touching. Why? Because through the wire they were touching. An electrical field was connecting them. So many times, if an electrical field connects something, you will not model that field as a separate component, and you will not model the interaction matrix and the everything plus, 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 minus, minus, minus. You would simply say, oh, they are able to interact, they are able to communicate, they are touching. Are you with me? So in that sense, we are touching. हम थोड़ा सा इवॉल्व कर गए. हमारी जो पहली अंडरस्टैंडिंग थी इंटरैक्शन मैट्रिक्स की, दैट वाज दैट only when there is a physical touch we say a touch. Now we have, because we have understood fields are there and fields are actively available, we may say that even in the absence of field and even in the absence of physical touch, there could be a touch happening through one of these fields. And depending on what system we are modeling, if that is the field, that is the main field of relevance, we would say they are touching. Okay? And we looked at quite a few examples. We reviewed the example of the hydrofoil. We reviewed the example of the monkey and the orange orchards. We reviewed the example of how to measure the length of a snake and uh, got introduced to the substance fields in that manner. And then what we had done was we had gone back to our working desks to refine the problem and work towards a solution. So all of you have received the notification for the final presentation, the solution, and everything has to be ready by then. So that was where I wanted to us to focus our energy and effort on. Project का कितना % grade है? What is the weight of the project in the final 100% score? I think 50% is the weight of the project. So I want you to score well. So therefore, we have been spending some time on the project in the class also. So today we will look at another ideation method. It will not really give us a, or this ideation method is, if you notice in the section of uh, problem identification. So it's not a solution finding thing, but even in the context of problem identification, it can give you directions as to where you should think of your next product to be, or where you should think of your solution to be. It's something like 9 screens. When we did 9 screens, we saw, okay, historically, this was how it was done. Today, this is how it is done. And in the future, we have to now ideate and imagine how it will be done. So this also is something like that. And it can help you choose from various alternative solutions that you have, choose something which could be relevant in terms of time. This is called Trends of Engineering System Evolution, TESE. And this is a very powerful uh, analysis that we could do. And Again, just like all other tools of TRIS, it is a statistically relevant tool, or it is a statistically analyzed tool. TESE are statistically proven directions of engineering systems, de- engineering system development. They describe the natural transition of engineering systems from one state to another. And these are statistically true for all kinds of engineering systems. So again, यहाँ पे सब statistically है. That doesn't, what that means is that you may find exceptions to it. But we're talking about statistically, this is how things would move. Because this is how things have moved until now. So this is how the things would move even in the future. Now, आपको कहीं exception दिख गया, ठीक है, it is fine. In fact, you may find that engineering systems and different states of evolution may coexist. For example, आज भी 2G, 3G, 4G, 5G networks coexist. There are different states of evolution of this communication network, but they coexist. And 2G की जो अपने significance है वो है, it will remain. Because there will be so many devices which would not need a lot of data to be transferred, but they want very low cost, very low bandwidth. So 2G will continue to be there. But then applications like what we use, gaming and other stuff, browsing, we will need 5G, we will need 6G also. Engineering systems will evolve, but they will coexist. And this is where this understanding of TESE becomes very important for you as engineers. Because if you, suppose आपके पास 4 ideas हैं, in which of these 4 you have to choose 1 or 2 which you would want to patent or do something about. If you understand TESE, the trends of engineering system evolution, you will focus on ideas which are relevant in the future also. And you will focus your energies on making that future happen early instead of investing your energies in something which is anyways going to be replaced sooner or later by some other invention. Are you able to see this? So abhi tak humne, and this is where this problem identification tool I am bringing in now and not earlier. Till earlier, we had looked at problem identification tools as a mechanism to find easier problems to solve, cheaper problems to solve, so that with minimum effort, we are able to get the desired output. However, today when we are talking about this section of engineering system analysis, we are saying that you already have some solutions in mind. How do you choose from amongst them so that your invention, your solution is relevant for the future also? Are you with me? So this is the distinct difference in character of problem identification tools that we did earlier and this tool. Is that okay? So this is to make your solution evergreen in a way. Not evergreen, but okay, relevant in the future. If you file a patent, it will be worth filing because people will want to use it in the future also. Not that, oh, it was relevant 5 years back. I filed a patent. Now the new technology has come. This also is a means, if you are an entrepreneur, to leapfrog your competition. So if everyone else is doing something, they have something available in the market, some technology is already available. If you understand the trends of engineering system evolution, you can already leapfrog your competition. Even when you do patent reviews and patent search, you say, oh, this thing is patented and protected. You could use TESE to leapfrog a patent also. So that is where this tool is very different from other problem identification tools. TESE will not give you a solution, it will give you a new problem to solve. Or it will tell you which solution to prioritize on. Are you getting it? So these are statistically relevant or statistically proven directions of engineering system evolution. And the biggest trend is trend of S-curve evolution. How many of you have heard about S-curves earlier? S-curves. So Actually, आप सबने उनको देखा होगा. You all of you must have seen S curves earlier. They are like, have you seen such a curve? What does this curve represent? आपने कहाँ देखा है? हम बहुत लोगों ने नॉट करा देखते ही कर्व को. Where have you seen this curve? This kind of a curve? स्कूल में भी देखा होगा एक्चुअली ये वाला कर्व. मैथ्स में देखा है. ओके. आईडी वर्सेस वीजीएस कर्व ऐसा होता है. ओके. कंपनीज के पोर्टफोलियो में देखा है. सो बिजनेस स्टॉक ऑफ एस कर्व्स. ओके. एक्चुअली किसी भी नेचुरल प्रोसेस को अगर आप न्यूमेरिकली पुट फोर्थ करोगे तो आपको एस कर्व की तरह दिखेगा. फॉर एग्जांपल, सो दिस कर्व वाज फर्स्ट established or recognized when an experiment was done on the growth of bacteria in a petri dish. So what was seen was that initially the bacteria only grow slowly, and then at once their population increases, and then that stabilizes. Now it cannot grow anymore. So what is happening here? Initially the bacteria are very few in number. आपने खाली छोटू सा drops of bacteria डाला. Very few bacteria were there. And even though they were growing exponentially, it was not visible to you. So this curve, this part of the curve is actually exponential. So जब आपने कहा मैंने मैथ्स में कहीं देखा है तो because this part of the curve is actually exponential. आपने यहां तक देखा है. But here something else comes into picture. So it starts to continues to grow exponential, but then something happens. What happens? Bacteria के context में, if we ask. No, the amount of resources in the petri dish are limited. They can no longer support that kind of growth rate. So the growth rate starts to slow down and then it stabilizes. And in fact, after that, it starts to plummet. What I mean to tell you is that if you stay on any one S curve, even though initially you will see that you are growing exponentially, sooner or later you will stagnate and you will die out. And that is where the trend of S curve evolution comes in, that you evolve in S curves. Okay. And once you know that we evolve in S curves, when do you think you as an inventor or you as a designer should reinvent your design or launch a new product or a new version of the product in the market? Here? Should you launch the new S curve here? Or where? Where would you want to launch your new S curve? So I'm hearing somewhere over here at the time of saturation. Okay. Any other ideas? Let's take an example. Let me just use the other side of the board now and let me show what happens. So let us say, but I need different color pens also and working pens. If you're not able to see it from that back, please come. Feel free to come to the front. So, person one, and now I'm talking about S curves for your careers. Okay, how you redefine your careers or how you take the next jump in your careers. Take the next jump may not necessarily mean promotion. Take the next jump means next challenge where you get to learn more. Okay. So there's person one. This is the S curves that we have for our careers, let us say. This person followed the advice of someone over here and said, okay, once this stabilizes, then I will launch the next S curve. This stabilizes, I will launch the next S curve, and so on. Okay. There's another person who says, oh, I notice that my growth is turning from exponential to linear. So my growth is turning from exponential to linear somewhere here. I will launch my next S curve here. Again, it's turning from exponential to linear over here. I will launch my next X curve over here. Again, exponential to linear here, here. Exponential to linear here, here. What happens? You notice that whichever level we are talking about, suppose we're talking about this level, this person reaches there early. As a entrepreneur, as a designer, as an engineer, as a human being, as soon as you see slowing down of your rate of growth, you're continuing to grow. As soon as you see slowing down of your rate of growth, that is when you should launch the next curve. Are you able to see this? Because otherwise, you will continue to grow, but the pace will be slower. And by the way, now at this age means whatever age you are in 20, 21, 25, 28, whatever is your age. Okay. At this age, no one else is going to tell you that you need a new curve. You have to be alert and you have to yourself identify what should be the next curve for you. You have to yourself reinvent yourself. See, snake भी होता है अपनी skin छोड़ता है ना. Do you know for the eagles what they do as they grow old? They go onto a hilltop where, for example, no one else can reach, and they actually remove all their feathers and they remove all their talons. And then, because they have no talons, no feather, they can't fly, they can't hunt. सामने कुछ है तब भी उसको पकड़ के नहीं खा सकते because the talons are not there. They actually are starving. They are struggling. But then the new talons come which are sharper. The new feather come which are more fluffy. And then they take flight again. So what I mean to say is S curves are not just for engineering systems. The trend of S curves is so universal that animals have it, we have it, our careers have it. And if you understand this trend, you can ride the wave. If you do not recognize it, you will just drift. Are you able to see this? So we've moved to philosophy from invention and problem solving. But this is important to realize that these trends are not just trends of engineering system. At least this top trend of S-curve evolution is not just for engineering systems. It's everywhere. Okay. And now, when we talk of this trend of S-curve evolution in the context of TRIZ, what we say is that this curve represents the growth of number of patents in any given particular technology. For example, in memory compute, the number of papers and patents you start to observe, you say they will at once ramp up. And then, after a point of time, the interest will wane. There are so many solutions in the market. No more space for others. Or people will just make do with whatever is available. Time is gone. And the number of papers will plateau. After some time, they will come down. If you have done some literature survey, you will realize that you might have come to a topic for which last set of papers were 5 years earlier, 10 years earlier. You want to go and publish this paper into a journal, they say, oh, is this topic even relevant now? Because what has happened? The S curve has not only plateaued, it has kind of died down. अब आप पेपर डाल भी रहे हो, you want it to at least remain stable. They will say, no, we don't want to publish. Why? Because something else, some other better technique might have come into picture. And until you compare your results with that better technique, that next S curve, and say, oh, I'm actually using this to leapfrog here, they will not see the point. They will reject your paper. That doesn't mean आपका काम अच्छा नहीं है. That simply means that they have for themselves killed the starting point that you talked about. They say, oh, this S curve is gone. You have to prove, no, you're not talking about this S curve. You're talking about the next S curve and you've moved on to that. This is the new trajectory that you're opening. Are you able to see? So, every technology. So, अगर आपको एक technology में आप enter कर रहे हो, suppose you are an entrepreneur and you're picking up a technology, and you see that there are very few people in the field, you will struggle big time to make a market, to make sales also. Why? Because the market doesn't even recognize, or the market doesn't exist, let us say. Okay? But if you see that, okay, there is a ramp up happening and you are entering the market somewhere here, you're entering in a golden phase. Because now many people will climb the bandwagon and lots of things are going to happen. Just by the virtue of you being there, you will just flow with it. Okay? But beware, this is not going to last forever. You have to always see, is there another S curve that could be in the making? And you have to jump there also. Again, that S curve is in the making, so it will be slow initially. But soon, if that S curve catches on, it will also ramp up. So कभी भी आपको अपने जो next S curve है, वो एक पे bet नहीं करना होगा. You want to bet on 2 or 3 which are exciting to you. And one of them may catch on. Anyways, if you have targeted to enter into an S curve early on, then you have margin. ये वाला नहीं भी catch on करा तो दूसरे वाला, तीसरे वाला, you can always try. But if you have waited until here and the S curve doesn't catch on, what happens? You start to fall. And then you are in panic mode. Are you able to see this? So this trend is something that each one of you should be very, very clear about. And evaluate different parts of your life, different dimensions of your life on this trend. Not just engineering system, but different, आप कौन सा टेक्निकल है तो कौन से रिसर्च में आप काम कर रहे हो, what subjects are you learning, what is the kind of state that is happening here, and so on. ठीक है? So now, why does this happen? Why does it happen that things at once increase and then they start to plummet? So होता क्या है? Initially, when the growth is very, very slow, the cost of your product is high. You are still exploring which features are there, which are relevant. So you overload your product with lots of features, lots of functionality. Okay? Look at any domain. Lots of functionality. Oh, overdue ho jayega. The cost is high because lots of features are there. It was not really needed. So then some features start to emerge as main parameters of value. Initially, you did not know what is an MPV. You just entered into the zone. And then you realize, oh, these are the MPVs. Once the MPVs are identified, then people start to improve the implementation of those MPVs. And that is where this thing starts to happen. Where the real pickup happens, at that point of time, the implementations have improved sufficiently to become cost friendly. So the value is continuously increasing. Initially, there was lots of functionality, but low features. But the cost was very high. Then some functionality was stripped, cost was stripped more, or the functionality was further enhanced because MPVs identify हो गए, तो उन MPVs पे focus करके started to enhance. And the cost remained same or started to fall because now more efficiencies as more people pick up. And then as more and more people pick up, the scale starts to figure in. Just because of scale, the price would start to fall. As the price starts to fall, functionality remains same, value increases. After some time, price can no longer fall. You almost become a commodity. And if you do not increase the functionality or you do not strip down some features and then reduce the cost, you will start to stagnate or probably fall down. So feature phones से लेके आज तक की अगर हम जर्नी देखें, feature phones में MPV क्या था? Just calling. Today, calling is not even an MPV. But feature phones still exist. Do you realize? Now, what is the MPV there? Because of which feature phones still exist? Cost. It is so cheap and multiple days of battery life. 7 दिन तक उनकी battery चल जाएगी because they only do talking. No battery wasted in browsing and all that crap. Old people find that thing very simple. Eyes नहीं चाहिए. Oh, those feature phones had those physical buttons which also had braille on it. Those of you have seen those phones. So you don't really need to see. आपको पता है ये 10 ही बटन है. मेरे को किसी को डायल करना है तो ये कर सकता हूँ. एक बटन को हार्ड प्रेस करा, स्पीड डायल हो जाएगा किसी का नंबर. My son or my daughter, I can call. That's one speed dial. You can't do that with your uh, this phone, touch phone, because keypad लाना ही अपने आप में जल्दी हो सकती है उनके लिए. So that is the parameter of value, main parameter of value that they are still holding on to. Therefore, the market is there, but a small niche market. Major market has been taken over by something which has far more functionality, which is far more feature rich. Pricier also, but not as pricey also. There are phones which offer almost all those kind of features, not to the extent that premium phones offer, but at a very reasonable cost. 5,000-6,000 mein you get good big screen phones with all the functionality, same features. Not the same quality, but similar features. So that is what S-curves is. So this is all happening because there is an increasing value. So आप कभी भी कोई भी solution evaluate कर रहे हो, आपको ये देखना है, am I increasing the value? Value means total sum of functionality divided by total cost. Are you with me? Then, how do people increase value? That could happen through multiple different trends. One trend could be the trend of transition to the super system. That what was in the super system, now I have integrated into myself. Or what I used to do myself has moved to the super system. For example, a phone today integrates a camera, a music player, and everything in it. So it has integrated the super system into itself. Or today you do not any longer need 1 GB or 1 terabyte of memory physically with you. You have offloaded that function to the Google Drive. How many of you have pen drives today? Very few people. There was a time when everyone had 3 or 4 pen drives with them. Why? Because, I have to carry my data wherever I go. Today, all you do is just mail yourself something and then that is retrievable there. So what you have done, you have transitioned to the super system for that functionality. So the pen drive market is gone. Are you able to see this? Then trend of increasing completeness of system components. Uh, in the early phase, over here, we do not even know which are main parameters of value. We just have an idea that this market would need, people would need this. When people start to use your product, they start to think, oh, I need that feature also. And I'm not just talking about products in terms of a product that you will pick and use in your hand. I'm talking of your software products. I'm talking of your hardware designs, anything. आपने एक नया circuit बनाया, आपने एक नया software बनाया. As people start to use it, they give you feedback. And you realize, oh, this was so obvious. I have missed that. So you start to add those features. What is happening? More functionality is getting added in the next version at the same price. So value is increasing. So हमेशा ध्यान दो, whatever we are doing here should be driving this. So you complete the system, complete different parts. Oh, इसका UI, I have made it more interactive. हमने जो पूरी बात ही करी, that main parameters of value identify करो और उसके बाद अपना MPV define करो, MVP define करो, minimum viable product. It means it is a minimum viable product. It is not complete in all aspects. From minimum viable product to a full product, what will you do? You will complete system components, add more value, and then you will reach there. Are you able to see this? Now, iska sub trend hai, trend of elimination of human involvement. What happens in the minimum viable product? You say the user can decide this and tell me. But you also say that in my final product, this will be automated, is it not? So what are you saying? In circuits, you may say that, okay, I will depend on these 5 signals to come from the system level. Later you say, oh, my feedback will close this loop. So what is happening? Human involvement, or let us say external involvement, is reducing. Why is this reducing? Because my components are becoming more complete now. They have their feedback loops also set in now. So this feeds this, and this consequently feeds the trend of increasing value. Are you with me? Any question until here? Then, trend of increasing coordination. A system has 10 different components. They do not coordinate well amongst each other, because of which system has some problems today. You apply TRIS, you say, oh, this interaction is not sufficient. I will do this so that this interaction becomes better. What are you doing? You are improving the coordination. As a result, some problems have come down. Market can increase. Price can be reduced because now those patch-ups don't, or the price, your price may not reduce, but what happens? The cost of ownership for the user reduces. What is the difference between price and cost of ownership? What is the difference between price and cost of ownership? Price मतलब मैंने आज मार्केट से कितने में खरीदा. How much did I purchase this thing from in the market today? And what is cost of ownership? This is what I purchased. What is cost of ownership? Which we are spending to keep that product functioning. So what is the cost of, what is the price of, let us say, Honda City? 15 to 20 lakhs, depending on which model you're talking about. What is the cost of ownership? Oh, you have to pay the road tax, you have to pay the uh, insurance, you have to, do all those things. So that is the cost of ownership. Number of times you have to go to the service station, that is the cost of ownership. So when you improve the coordination and different components of the engineering system, what happens? They work more in a more lubricated manner. There are fewer breakdowns. Your system is available more time. Your system is more profitable. So per day ownership has reduced. So cost of ownership has reduced. Cost of ownership reduce होते ही value increases. Functionality तो वही थी, cost कम हुई, तो value increases. Now price may not have changed, but just by the virtue of increasing coordination, value has increased. Are you able to see this? There is another adjacent trend to this, which says trend of uneven development of engineering systems. Now, this is a very interesting trend. This trend is about that, let us say a car itself, EV car, नई है, तो अभी, do you think EV car is at the peak of its efficiency today? No. But is nothing in the EV car at the peak of its efficiency? So the EV car totally is not at the peak of its efficiency. But there's nothing in the EV car at the peak of its efficiency. No. The wheels, they remain the same because they have been made efficient through years and years of innovation. Are you with me? The axle remains same. Motors might not be at the peak because this is a new way these motors are being used, are being driven. So what is happening is that in any engineering system, different parts of the engineering system will be at different levels of efficiency because they developed in different time zones and different systems, and they were incorporated in your system later. Are you with me? So this trend that each part will develop independently actually is a trend. And क्यों ऐसा होगा? Because you know that, for example, today you already know that battery life is the biggest, what do you say, naysayer for EV cars. That every 7 years you have to change the battery. This is the biggest cost in the EV system, or this is a huge cost of ownership for me. Now, everyone across the world is innovating on battery. Somehow extend the life, make them such that they can be reused, refurbished, whichever way. Huh? So what is happening? Battery system is evolving at a much faster pace than the motor system because it is good enough abhi. Battery system will reach its peak of efficiency at a different rate than the motor system. Are you able to see this? So, as a consequence, parts will grow in an uncoordinated manner, and they will soon, as more and more parts reach the peak of efficiency, they will be more coordinated. As they get more coordinated, they increase the value. Are you able to see this? Now, then there are these subtrends. Trend of increasing controllability. To bring about those coordinations, you want more control. For example, अभी इसने कहा बैटरी को छोटा छोटा बना दो. So that I have more control, I can change only some part of my battery and still have higher efficiency. So more controllability at user end. Or trend of increasing dynamicity. That छोटा छोटा बना दो was I should dynamically be able to replace some part of the battery, and that gives me more control. That gives me more control means I have better coordination in different parts, and therefore I increase value. These are subtrends that lead to trend of increasing value, or trend of increasing value essentially means the law of S curves. Are you with me? Then, trend of increasing degree of trimming. This is fairly obvious. As you trim more components, your system becomes cheaper. Trimming ensures that you have same functionality left. So functionality remains same, system becomes cheaper, value increases, S curve is being followed. Trend of optimization of flows. So अभी तक हम products की side पे थे. This is a trend of optimization of flows. That flows will naturally be more and more optimized as time passes by. Even when a river changes its course, initially the flow is very turbulent because there are so many stones on the path which cause that turbulence. But after some time, erosion happens. The most disturbing stones either roll down the stream or they get eroded, they become rounded, they do not offer as much friction and turbulence. So flows become more optimized. Same thing happens in engineering flows also. Whatever part of the flow is causing a problem, as a engineering system manager, you will focus on them and remove those parts or clean up those parts. So this is a trend which again leads to increase in value. Increase in value means you're on the S curve. Are you with me on this? Any questions until here?
सर जैसे डिग्री ऑफ ट्रिमिंग तो हमने वो पीट फिल्म वाला एग्जांपल देखा था जिसमें रीडिंग किया रहता है तो उसमें एंड में आते आते हमने सब कुछ ही ट्रिम कर दिया तो उसकी वजह से कहीं ना कहीं कंट्रोलेबिलिटी पे इफेक्ट पड़ा ना हमें उतना कंट्रोल
So I did not say that trimming leads to controllability. No, no, no. These are independent trends. Just because of trimming, you are able to increase value. That is one way to innovate. So I would say that then whenever you are faced with the problem, you have 1, 2, 3, 4, 5 major ways to innovate. Major directions to think about. Oh, should I trim something? Should I transition to the super system? Should I increase the completeness of some parts? So these are the questions you have to ask to be able to find an answer. And then decide, oh, I will use this path. For example, abhi thodi der pehle, there were a few people in the class who came to me and asked, sir, we are working on IMC and we have found this, 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 this. This is a question they need to answer. Do we trim something more and therefore become innovative? Do we transition to super system, put something onto the super system or merge something so that there are no two systems, one super system is just one system now? What do we need to do? This is a question they need to answer. So आपको अपनी जर्नी में बहुत जगह पे आएगा, what should I do? To follow the S curve, you could do any of these things. Trimming does not lead to more controllability. No. Is that in the line? No. It is an independent way to improve value, increase value. It may or may not. I don't know.
So here value just means cost and functionality.
That is how we define value initially also, na? First few sessions when we talked about TESE, we said value is total sum of functionality, features that I have, all the functionality that my different components do upon the cost of those components.
Because elimination of manual intervention doesn't always increase the value effect of general if we talk about general terms of value. But for the definition we have defined, then it's
So I will give you one example of what you're saying. So because there was this completeness of systems wala thing, trend that things will become more complete, lesser human intervention, and that is the way things would move. So Pillsbury, you know this brand, Pillsbury? It's one of the very big, यहाँ पे भी है, but it was a US brand. So what it did was Pillsbury introduced baking powder, a baking mix. In the US, it's introduced baking mix. So what was happening was people would bake cakes at home and they would struggle. कभी मीठा कम रह गया, कभी we this is the second time in this course we're talking about cakes. We did that flow analysis on cakes already once. So we see so कभी मीठा कम रह गया, कभी oil कम रह गया, कभी कुछ हो गया, कभी कुछ हो गया. So people were struggling. Cakes बना रहे थे, people would still bake cakes for their children on their birthdays. And but कभी बच्चे दुखी हो गए, मेरा बर्थडे आपने इतना गंदा केक बनाया. So what Pillsbury thought was, oh, let me give them a mix. It's like 2 minute noodles. Maggie सबने खाई है? How many of you have had Maggie ever? प्रिथा ने मैगी नहीं खाई? खाई है. Okay. So 2 minute noodles की तरह they said, oh, 2 minutes cake. 2 minutes cake नहीं, but okay, all you need to do is just mix this powder into water and put it in the oven. We'll tell you what temperature and 10 minutes में आपका 20 minutes में आपका केक बेक होके बाहर. They were like, wow, मजा आ गया. We have reached the peak of automation, elimination of human involvement, increasing of all सब कुछ. This is the peak of everything. That product did not sell in the market. Initially, it sold. Then no one like it was a failure. Why? No, it was cheap. It was cheaper than all those cakes that you would have spoiled. No, they had multiple varieties of these mixes available. Vanilla bhi hai, chocolate bhi hai, ye bhi hai. They made a whole range. People are anyways. So see, they had a target market. They started to increase the market share, but then it plummeted. Market rejected the product. No. अरे बट बढ़ के कम हो रहा है ना, तो उन लोगों को पता था, वो भी अब लेना बंद कर दिए. इसी के पॉइंट को मैंने बोला था ना, आई विल एलैबोरेट योर पॉइंट ओनली. सो what mothers felt was, so they made the cake, it came out perfectly. But mothers wanted to bake that cake for their child. They wanted to do something. And here they had to do nothing. A child could bake the cake by himself. The whole essence of baking a cake for my child on my birthday was lost. So what was the next product that Pillsbury came with? No? Same cake ke liye. They said, now we will give you ingredients. We will give you a cake baking set where you will mix powder 1, powder 2, powder 3, powder 4 in this many milliliter of water. You will let it stay for 20 minutes or 5 minutes or whatever, and then you will put it in the baking oven. And the sales went up like anything. So elimination of human involvement is not always good. Where human factors like emotions are involved, involvement may be necessary. Where security is involved, involvement is necessary. Where something which is too private and too intimate to me is involved, involvement is necessary. So that kind of, so मैंने वही कहा था that you will always find examples where no further removal of involvement will happen.
Example of Europe that they have introduced a mechanism called eye border control, which is applied at the borders, and then there was some algorithmic bias at the mechanism, which is doing that if someone is black, they are just stopping them from coming inside the border, and someone who is from a white race, they are allowing him to
Immigration gates पे. Mhm.
This was a bad thing, so it got eventually caught, and then the whole mechanism got
Replaced by human.
yes, then philosophers talked about, that there must be a human intervention when there is a when the talk is about security or revenue. So that's why.
Okay, so there are many places, many events where you will see that removing all human involvement will not fly. So you're getting?
In Russia, they fixed the entire automated system where, like, if there any nuclear burst themselves, they get would sort of sense it way in advance and send
An advance notification.
mistook of flight, the automated, it was a self-automated system, so mistook of flight for a nuclear weapon.
And it put it down. Many passengers got killed.
After it was where the person, because there was after they added human intervention, and the second time they were able to avoid the world war because of the human intervention, then the security guard there, he told Russia that it's not a nuclear weapon. So they failed.
Yeah. So human involvement will be required when it comes to mission critical or life related things or where emotions are involved. But for engineering systems, this trend would still be there. आपके engineering system के लिए कितना involvement is the peak, you have to judge. Is that okay? Any other questions? Any other thoughts? Okay, so we have understood everything. I will now quickly take you through the slides. Is it okay? So as an engineering system evolves, the evolution of each main parameter of value describes an S-curve S-shaped curve in time. Okay, and MPVs are usually at different points of their respective evolutionary development. Some MPV will be at first stage, something else will be at transitional stage, something else might be at their fourth stage. So when something is at their fourth stage, you would want to trim it. Trim it out because now its value is probably decreasing, but it is increasing the cost for you. So S-curves can be built, as we just discussed, for a wide range of things. You could build it for evolution of each of your components. You could build it for your entire system. You could build it for your careers. You could build it for your, life in general. So many things you could build S-curves for. And this was what I was talking about when I said that in the initial phase, when the MPV is just about to get developed, the number of inventions start to increase. And the level of invention, initially it's very high because it's the first fresh new idea. You will say that after some time, the novelty of ideas or the value that these ideas add would start to reduce. There comes a kink over here where we say now the system has identified all its MPVs. Everything is at a reasonable level of maturity. And now we want to improve efficiency. So now the kind of ideas that come in this phase are the ones that improve efficiency. Not functionality, not feature set, but efficiency. And this phase actually gives the shift transition to the exponential growth at that level. जहां बहुत सारे लोग अब इसको pick up करना शुरू करेंगे, scale आएगा. And after some time, you see that the number of inventions will fall down. The invention level is already low, and the profitability will also kind of plateau. It was because of this increase in efficiency that you started to see improvement in profits over here. Are you able to see this? So we've already discussed all of this. I'm just taking you through quickly now. And as I said, you have to initiate the next curve actually well before your second stage or third stage is about to be entered. If you do it later, you will see that something is kind of stagnated and then your overall growth slows down. So this is about the trend of increasing value. An old computer was like this whole big, ये एक रूम क्या पूरा कॉरिडोर के जितना बड़ा एक कंप्यूटर होता था. Hmm? And today you have a computer in your pocket. Actually, I should not even be showing a laptop. You carry a computer in your pocket. A trend of transition into a super system. There was a printer, there was a scanner, and there was a photocopier. Today you have an all-in-one. It does everything. Hmm? Uh, Trend of engineering increasing dynamization. Uh, you will see that things move from being monolith to a joint based system to a multi joint system to an elastic system to a powder. So you do realize हर जगह पे dimensions of movement are increasing to liquid to gas to fields, finally fields only. एग्जाम्पल के तौर पे आपका एक सिंपल रूलर होता है. Then you have this kind of a folding ruler, you have a measuring tape, and you also have a laser tape, laser ruler. And do you realize now, इसके आने की वजह से आपका सिंपल रूलर गायब नहीं हो गया. It is a completely different market. But this simple ruler also exists. Every school child has a ruler in their pencil box. आप में से कितनों के पास अभी रूलर होगा? So a few of you also have one. That this one came into picture doesn't mean this vanished. Are you able to see this? So trends of engineering system evolution do not predict completely vanishing of any particular engineering system. What it says is the technique would evolve. This is clearly more high tech than this, is it not? So the techniques would evolve, the technology would evolve, and if you want to be at the rising, at the uh, leading edge of the technology, you have to be alert about this engineering systems. Okay, so this much for trend of engineering system analysis. I would want us to work on our projects now. Please sit as project teams and let us apply whatever tools we have on our projects. Again, I want us to be ready for the presentation in good stead. So we have about 50 minutes left. I would want you to work on your project. Yeah, laser. अब लेजर के अंदर एक अलग एस कर्व है. Yes, you are absolutely right on that. Because अब वो टाइम ऑफ फ्लाइट के थ्रू आप कर लेते हो. आपके हर सभी के कैमरा के अंदर टाइम ऑफ फ्लाइट है फॉर डूइंग द फोकस. वही तो वो करता है, डिस्टेंस मेजर करता है और फोकस रीसेट कर देता है. पता भी नहीं लगता आपको. वो एस कर्व से इवॉल्व होके वहां पहुंच चुका है. Yes. हर जगह पे हर एमपीवी का एक अलग एस कर्व है. ठीक है.